Good afternoon, everyone. Welcome back to the second session of the day. This will be a hands on practical session. I'm happy to welcome Dr. Poornima Singh Thakur, Assistant Professor at IIIT Gwalior. She earned her PhD from IIITDM Jabalpur, focusing on plant disease identification using interpretable and lightweight deep learning models. Her research interests include computer vision, machine learning, deep learning, vision transformers, explainable AI, blockchain, and big data analytics. We look forward to gaining some valuable insights from her expertise. Now, I request you, ma'am, to kindly take over and begin the session.
Thank you very much, Gaurav. Very good afternoon to all the participants present over there. So, in today's session, we will be starting with, I think my screen is visible. We are going to start with building a basic convolution neural network model that is for image classification using the dataset CIFAR-10. So, the CIFAR-10 dataset is basically from Toronto University. I think, just a minute, I'll share my entire screen. So this particular CIFAR-10 dataset, there are two versions of CIFAR dataset. One is CIFAR-10 and one is CIFAR-100. Where 10 or 100 belongs to the number of classes in the dataset. So there are 80 million tiny images. Why tiny? They are saying that because each image is of size 32 cross 32. But these are color images. So it have RGB color channel. CIFAR-10 and CIFAR-100 were created by Alex Krizhevsky and Vinod Nair and Geoffrey Hinton. Sir Geoffrey Hinton, I think you know him very well. So the CIFAR-10 dataset having around 60,000 of the images each of size 32 cross 32, color image in 10 classes. With 6,000 images per class, that means the dataset is balanced. There are test images in the dataset. So let me just show you the image here. I think this is much better visible than there. So the very first class is airplane, the second one is automobile, the third is bird, and then cat, deer, dog, frog, horse, ship, and truck. These are the 10 classes present in CIFAR-10 dataset. So you can download CIFAR-10 dataset from the official website of Toronto. But this particular example is basically dedicated with the help of PyTorch framework, which is a deep neural network based framework mostly used by the researchers. So we'll be doing it in PyTorch. So the dataset will be directly accessed from the PyTorch dataset package. So this particular notebook I'll share with you, but before that, let's start with the very first part, that is creating a Jupyter notebook. I request all the participants, please open your Google Drive and create a new Python notebook, because this is a hands-on session. So I want your participation so that you can type the code with me. And if in between, if you have any doubt, you can write in the chat box, or you can even unmute yourself if it is permitted. So I request you all to please create a Jupyter notebook. I know that you may be familiar with Google Colab notebook through Drive. Just open Google Collaboratory notebook in your Drive. We are going to write the code line by line instead of accessing the code from this particular notebook, so that it will be like, for you, it will be familiar. So I have renamed the notebook, then I will be connecting it to the Google backend engine that will be providing me CPU, GPU, RAM, and other necessary capabilities to execute this particular code. So participants, are you familiar with PyTorch? Can you just respond in the chat box? Are you familiar with the PyTorch? Okay. So now we are connected with the resources. So the resource provided by Colab is Python 3 Google Compute Engine backend. And this particular resource is assigned at this particular time to 34. The RAM is 12.7 GB and this space is 107.7 GB. Next is I'm going to change the runtime from CPU to GPU so that will be the training will be executed faster. Next is we have to import some basic libraries. The very first is Torch. So as you are familiar with PyTorch, if you are not, I can explain you that as well if needed. The very first library that you will be needed is Torch. So I'm importing Torch. Next is because we are going to create a convolution neural network. So you have to also import torch.nn that contains all the neural network based layers and other necessary components. Next is about, because this is a image classification task, so that's why you will be needing torch vision package. So these are the basic libraries. Other than this, if anything else will be needed, we will be importing whenever it is required. So we are going to use CIFAR-10 dataset. So it is available in PyTorch. You can see in the torch vision dataset, CIFAR-10 is available. These are the parameters needed, whether you want train or test. If it is true, then training, false, then it will give you test data. Transform is to perform various pre-processing steps like normalization and converting the image to PIL and other thing, converting it to like image to tensor. And whether you want to download the data on your local PC or not, and it will be returning you image along with the target. So target is the label. So we are going to write the same in our notebook. And then the one more thing. The last one is the transform that we have to first of all define. So that transform is there in Torch Vision's package. So I'm creating a local variable transform, which will be having a pre-processing step. So it is there in the Torch Vision package. So Torch Vision dot transforms and then dot compose. So we are going to create a transform which will be converting the image to tensor, and then the images will be normalized in between 0 to 1. So the parameters will be in the form of list. The very first will be torch vision dot transform dot to tensor. The second one is the normalization. So the same way from torch vision we will be taking normalized function. So here you have to pass, you can see it is suggesting that we have to pass mean and standard deviation. So when you read, let me just show you this as well. You can see here in compose, you can even perform the augmentation, data augmentation part. So when you see the official, this particular page of PyTorch, you will see that in the normalized part, mean is 0.48, 0.556, 0.406. And standard deviation is 0.229, 0.224, 0.225 for RGB image. So we are going to use the same approach. So these values, mean and standard deviation, is calculated through various samples, randomly selected through the RGB population. So that's why these values, you can use 0.5, 0.5. That is not an issue, but this is the way they are doing after calculating it through various RGB images. So this is about creating the transform. Next is, there is a query, how you know that 0.4 is the mean and 0.229. I am not the one who has calculated. If you will see the documentation of mean and standard deviation of RGB image, you'll find out these are the standard values. Even you can use, if you don't know and you don't want to use, you can use 0.5, 0.5 and 0.5. That is not an issue, but when you are denormalization, you have denormalizing, then also you have to process the same way. Another query is why we are creating the transform. So we are creating the transform. First thing is, because when you are working with PyTorch, you need your data should be in the form of tensors. So it will be convert your data in the tensor, because initially it is in PII image, pillow based image format. The second is, the second step which we are doing is normalization, that is normalizing the pixel values in between 0 to 1. And other than that, you can use it for data augmentation. You can see here, there are multiple options. Center crop, converting PIL to tensor, convert image data type to float. Various pre-processing steps are there. So you can go through the entire transformation process, and then you can documentation, you can read and check other capabilities of transform composition. So that's why just for pre-processing steps, we are creating this particular transform. Next is downloading the data and then applying these two steps on the downloaded data. So the data set we will be downloading from torchvision.dataset.CIFAR-10. First of all, we will be downloading the train data set. So you can see it is asking route, that is the path where you want to save, training true or false, whether you want to download train data or test data. Transform we have already created, bool download true or false, like that you have to write. So suppose the path where you want to save is, suppose content comma sample data. There is another query. What about grayscale image? Do we need to follow the same step? For grayscale image, you don't need to pass three means and 3 standard deviation here. Instead of that, you have to pass single value. But definitely you have to normalize the images. Similarly, like that, for denormalization, you have to reverse that particular process. After root, the next parameter is train and then transform. Train is true because we are downloading training data. Next is the transform. So transform we have already created. That's all. Yes, currently we are downloading CIFAR-10 training data in this particular path. And then pre-processing. Both the steps are applied here on train data. Similarly, let's download the test data as well. Here instead of train, we have train true, we have to write train false, and then our test data will also be there. And one more thing is let's download it. This download option also. Now it is downloading train set and test set. You can see it has downloaded here. CIFAR-10 batches.py, CIFAR-10. This is the data, test batch, and these are the batches for training. Each batch contains some 10,000 of the images. So the data set we have downloaded. Next is we cannot load 10,000 images at once because of unavailability of like the GPU capabilities or CPU capability we have doesn't allow us to process such a huge amount of images at once. So generally we create batches. Those batches are shuffled after each epoch. Epoch is a step, like epoch is when once the entire data is passed through the neural network model, and again for the next epoch, your data is rearranged. That is, shuffling is performed so that the pattern your neural network is learning is not overfitted. Every time if same batch will be given to the neural network, it will be learning the same pattern. But if you will change the structure every time, it will learn the new pattern of the data. That is necessary to make your neural network more generalized. Generalized means if any type of pattern will appear to it, it can identify the class of that particular data. So that's why shuffling is necessary for training data. So let's create the batches of trained data set. So I'm creating it with the name train loader. So this particular thing, we have to load it from torch dot utils dot data, and now we will be reading this particular data loader. It is suggesting, but just ignore that because nowadays they are giving like AI in the collab as well. So that's why it is suggesting, but don't go through that, otherwise you will not remember the steps. So in the train data loader, you will be needing first of all train data set. Next is your batch size. You can see it is suggesting on the top as well as auto completing the sentence. Batch size I'm setting is suppose 32 because the number of size of each image is around 32 cross 32. So you can make it even at 64, 128 like that. And then the last one is shuffle. So we will be shuffling after each epoch for training data. When we talk about test data, that is test loader. So will be test set, batch size will be 32 and shuffle will be false. Why we are setting it as false? Because if you will change the test data after each, we can say maybe while validation or while every time you are rechecking on the test set, your batches will be changed. If your batches will be changed, then there are chances that your performance matrix will also very lessly, but it will be affected, maybe in points or something. So that's why test data set we don't shuffle. Next is about the class labels. So, because the class labels there are in teaser format, let me just copy from here. The class labels will be plain, car, bird, cat, deer, dog, like that. The classes will be there. So participants, if you want to run the same code in your notebook, shall I wait for some couple of minutes, 2 or 4 minutes, so that you can type it in your chat, like in your collab notebook? If it is required from your side, please, I'm giving you 2 to 4 minutes to complete the same code in your notebook. Then we will be going ahead. Is it okay? Okay, so I'm waiting for 2 to 4 minutes. Whenever you are done with this particular code, you can let me know through chat box that I can go ahead. This is, I can do that, but I'm copy and pasting the code in the chat box. But please, instead of copying it from the chat box, if you can type, then there will be, if there is any type of typographical error, then you can resolve by yourself. Instead of copy pasting, please write it in your notebook. I have pasted the code in the chat box. So whenever you are done with the code, please let me know so that we can go ahead with the next part. Okay, there is a query. Can you explain about epochs? So, dear, there are two things. One is about iteration and one is about epoch. So, iteration, maybe you will be familiar with while like writing the C++ based code. Iteration is when a single batch is completed. Epoch is when your complete data is once passed through the neural network model. Let me explain it with a very simple example. Suppose I have these 10 objects. Each object is having single example. One object of plane, one car, one bird, one cat, like that. 10 objects are there with me. And there is a kid, 2, 3 years kid who don't know what is plane, what is car. And we have to teach him or her that plane looks like this, like that. So once, if you will be following the same step, this is plane, this is car, bird, cat. So he or she will be remembering in this particular order. But that should not be the case. If because you can so to test the kid randomly, you have to even train the kid randomly. So that's why when you multiple time explain the kid about plane, car, bird, so every time it's better that you shuffle the order. If you will shuffling the order, then the pattern of occurrence will not be learned by the kid. So in the same way, we create epoch once the complete 10 samples are passed through the, or a complete entire data set passed through the neural network. Your batches of size may be 32, 64, which is passed once in a neural network, are recreated in a random manner. Okay. Another query is, could you please explain again why the test data is not shuffled? So why we are shuffling train data, I think it is clear to you all that if you will not shuffle the train data, the occurrence pattern will also be learned by the neural network and your data, like the model will be overfitted and the pattern will not be random while testing. And why we are not shuffling the test data, let me explain you that as well. Suppose plane, car, bird, cat, deer, dog, this is the pattern in the test data as well. And you are shuffling it again and again. So the batch is created. Suppose we are creating the batch of 2 instead of 32. We are creating the batch of 32. 2 instead of 32. And every time when you shuffle while testing, rerunning the code for test, your result may affect in a minor way. It will be in points, it will be affected because sometimes your model will capture that particular occurrence or sometimes it will not. But if you want your test result will be fixed every time, you don't want it to be changed. So that's why don't shuffle the test data. If you will shuffle the test data, your result will also be affected. I'll show you how it will be affected after training. Once, let us first make it shuffle false and at the end we'll make it shuffle true and see what is the changes we are getting. Okay, there is another query. We must apply only those pre-processing steps which don't change the input time. No, dear, this is not like that. That you cannot change the input size of the image because when you talk about CIFAR-10 or CIFAR-100 dataset, it is already it is already resized to 32 cross 32. If you want it to 16 cross 16, here you can make it as dot vision dot transform dot resize, pass 16 comma 16, so it will be resized to 16 cross 16. But it is not needed. The size is very small, so don't make it too small again, and don't even increase the size of the image. But when you are working with very large images, maybe of size 512 or 1000 cross 1800, at that time you have to resize your image in the pre-processing step. What is the significance of size in a neural network? The significance of size in a neural network is like that. I can show you the image, it is quite blurry, you can see. You as a human can identify it's a car, but it's quite blurry. So that means the information is very less about car. But when you increase the size of that particular image, suppose you are creating it as 64 cross 64, there are chances that the quality of the image will be far better. So definitely the size will affect. But if you will be taking too large size of the image, then the training neural network model is quite heavy. Because if one image size is 1000 cross 1000 and you have such 60,000 images, then you need some 200 GB of GPU memory to process your data. So when you read the research papers, you'll find out that most of the time the image size is around 224 or it will be 256 or in maximum it is 512 cross 512, not more than that. So the large images are scaled down to 224 or 256 or 512 to process. Can we go ahead? Okay, so data reading, pre-processing is done. The next part is, let's just plot some sample images from the data that is here in the picture and see the labels. So we have, suppose I'm setting the test size as 8 for now because I have to just show you 8 images from the sample. So we will be iterating over the test loader. So it will be giving you first, like just now. So it is the data and labels in this particular iteration. And then we will be, through this iterator, we will be accessing the images as well as the labels for printing. So we will be accepting the images and corresponding labels for 8 images. You see the image, you can see these are the value and the size is 32 cross 32 cross 3. So the PyTorch follows channel first order, that's why 3 is here. 8 belongs to the batch size, 3 is the channel, and 32 cross 32 is the height and width of the image. And these are the labels of the, like, so 3 belongs to 0, 1, 2, 3. So like that it is belong to the cat. And let me just plot the images. So for plotting, we will be going to use matplotlib. There is a query that can you just explain the concept of batch size. So there are batch size is the number of samples or number of images you want to pass as a single batch to your neural network. Suppose in your class you have 60 students and you some external is coming to take your Viva exam. So instead of calling all the 60 students together in a single batch, he or she may call maybe a batch of 2 students, 4 students, 8 students together, so that the process will be faster as well as accurate. If there are 2 external present, so they can even make the batches of 4, 8 like that. So availability of the resources, if you have higher availability of the resources, you can increase the batch size. Similar batch size, that is the number of sample in a batch. Okay, there is echo in my voice. Just a minute. Is it okay now?
Yes, ma'am, it is.
Okay. So let's plot these images and corresponding labels just to see what is there in the first batch. We have the images, we have the labels, and now we have to just plot it using matplotlib. First of all, we have to convert these images to, because these are in tensor, so we have to convert it into NumPy. So I'm importing NumPy as well. And then we'll be, first of all, converting the images and then plotting it. It will be, I'm creating a function IAmShow. It will be having your images and then labels. First of all, we will be creating the grid of the images. That will be using torch vision. Grid will be having all the 8 images together in a single row. Grid. And here we have to pass the image. And then write a few people for wrapping. Now we have to convert this particular image to NumPy. And then we will be plotting it to plt.im2. And then because you can see it is having channel first, so we have to transpose it. We have to make channel last. So for that we will be transposing it using NumPy np.transpose. This particular NumPy image we will be transposing and then passing the channel at the last. So 1, 2, 0 will be the order. There is a query, is it necessary to make channel last? Yes, it is necessary because matplotlib follows channel last property. However, pytorch follows channel first property. That's why to print it in a correct way, you need to transpose your image. Instead of 0, 1, 2, let's print the label name. We have the labels here in this particular place. So from classes, we can access the label. For label in the labels. So one by one, it will be iterating to that particular label list and then creating the label name. And then we can call the IAMShow function along with I'll explain all the query. Let me just complete it once and then I will be explaining the queries. Dot forget it here instead of comma we need. So you can see currently also the images are not properly well shown because the size is very small. Do one more thing, plt.text this of. So the very first image is of cat, next is ship, again ship, this is plane, frog, this is car and frogs. For even with bare eyes, we cannot visualize some of the images. Like for me, it is difficult to identify cat here and then car is okay. But the last one, frog, I cannot visualize it because the size is very small. And I'm copying this particular code as well in the chat box. And then I will explain whatever queries are there in the chat box. Please run the same code in your notebook. And there is a query, the final batch size for training test. No, you can even set batch size for test loader as one. There is no need that both the size should be exactly same. 32 for training we are setting and 8 for testing. One query was this. The second is it necessary to make the channel last? Yes, it is necessary to plot these images. If I will not do this particular step, you can see the images are not plotted because it doesn't have the channel property at the last. So it is necessary. Let me just do one thing. IMP without transposing. You can see it is saying in invalid shape 3, 36, 274 for image data. So it is from here. 274 is from this 32 plus 32. And 8 and 3 is from here 36. And 3 it is creating. So it's better to transpose your image. Next is what is data iterator. So data iterator is we are creating one iteration over your test loader. Iteration is that one by one your batch is batch is iterated or accessed through this iterator. And next function is calling the next set of the iteration. Another is some places you are having IM images and other is IM. So images and labels, I'm taking outside the function. Here I'm having images and labels. That is okay. But inside this particular function, I'm using IMG label name. So you can even use single IMG. But outside the names are different. Otherwise, it will be overlapping the variables. Is the batch size choice the batch size choice a choice to be made by the analyst keeping in mind the computing GPT? Definitely batch size should be not too small, not too large. And it should be like based on the size of the input image as well as the availability of the resources you have in your system. So can we go ahead now? We have done the data reading and pre-processing part. Next is about neural network building. So in neural network building, you have to create any type of neural network in PyTorch through classes. Inside that, you have to create two basic functions, but one is defined in it, that is initialization. And then the second is the forward pass of your neural network. There is another query. What is 120? Look, when you think about any matrix in matrix transpose, you have some data there in the zeroth index, or you can see row, column, and you are changing or shuffling column to just swapping column from row. That is transpose. So in the similar way, we are passing this channel from here in. So we are making channel height, width from of an image that is supported in PyTorch to height, width, and channel that is supported in matplotlib. So matplotlib Keras they support channel last priorly, you can change definitely that as well. This iteration, another query is about iteration. So this is for iterate over each batch of the data set, whether it is about train data set or test data set. Let's create the, please explain channel first and last. So suppose you have created one um, matrix. This is of size 2 cross 3. Suppose instead of 2 cross 3, I'm creating 3 cross 6 cross 6. Just remember 3 cross 6 cross 6. So 3 here represent that it's a RGB channel, that is color image. 6 cross 6 is the height and width of your image. So this is your data. This is your image data, 3 cross 6 cross 6. I can even plot it using Matplotlib. But for that, what we have to do, we have to change this 3. We have to pass this 3. This is channel first because 3 is in first. We have to pass it to last. That you can do using transpose function. So for np.transpose, first of all, the previous array and then which axis you want to swap. So we want that the zeroth axis should be at the end. So 1, 2, 0. Now, when you check the shape, so it's 6 cross 6 cross 3. Similarly, when you plot it, it's like this. And you can even plot it. Definitely, there will be some random values. These are some random values the rate it has created through the value in. Is it clear? What is the usage of 102 and 201? Okay, so let me just delete all these steps so that we can go ahead with the previous. Ma'am, I iterated next are like for loop. Definitely you can write the for loop as well. That is for loop only. So let's create the neural network. I'm creating the class CNN. First of all, you have to inherit the properties of or what we can say all the layers functionality available in torch.nn function that we have imported earlier as well. So nn.module we are going to inherit here. And next is here you have to define two functions. So first of all, I'm writing the function name, both the function name, and inside it, we will be writing the functionality. Define init. And inside the init function, we will be having the parameter cell that tells that you have to use the variables inside the this particular class. And second function that we have to create is forward pass. This is the structure in most of the PyTorch based neural network. You can definitely make necessary changes as per your requirement. Here also self variable will be there, or parameter will be there in the forward pass. And the second parameter will be the input. So input you can even write INP, input, whatever is okay with you. I'm writing X. These two functions we have to create inside any type of neural network using PyTorch. First of all, you can see it is suggesting. It is suggesting that make your init function as constructor. So whenever the neural network is called or class is called, this init function will be automatically executed. So we will be going the same way. We will be making it as an constructor. Next is you have to define all the necessary variable. So let me just write few things so that you can also understand the things. Self parameter is there because we are using class. So whatever variable you will be initializing inside the class, that you have to call with the help of self parameter. So the input size, what is the input size of your data set? Can anyone just write in the chat box? It's 32 cross 32 cross 3. This is about simple. I'm not talking in terms of PyTorch, just a simple input size. Suppose we are creating a convolution neural network where your input size is 32 cross 32 and our kernel size is 3 and there are total number of kernels. Kernels or filters, whatever is okay with you, are 32 with padding as 1. What will be the output size? Can anyone calculate it? Kernel size is 3 or filter size is 3. Number of kernels are 32 and padding is 1. What an input size is 32 cross 32. What will be your output size? Just write the formula as well and do, instead of direct message, can you write it for everyone? Is it allowed? Can you write the answer to everyone?
No, ma'am, they can't currently. We need to provide the permission for the same, but they can connect to you directly.
No issues, no issues. I'm just because everyone is, I want that. That is not an issue. I'll write the answer as well. So the output size is the formula I think you may know. N minus F plus full P and upon S plus 1. So let me just complete it. So this is the formula we follows. So N is 32 here. When you see N is input size. N is 32 cross 32, or we can say N is currently 32. F is 3, that is your filter size or kernel size. P is 1 and stride is not given, so make it as 1 if it is not given. Now I think you can calculate. If earlier there was some issue, you don't know the formula, can you calculate now what is the output size you will get now? $32. So that means you will be getting the complete, I want the complete output size, not only single pixel. What will be the complete output size of your neural network? The feature map, that feature map, you know, you may have studied in the first session of this particular day. Okay, exactly. The output size will be 32 cross 32 cross 32. Those who don't know this particular concept can you now calculate from next step. I'm not like removing this particular part. It will help you later on. So let's define the first convolution layer based on this particular example. So self variable, some all are asking why we are initializing self to tell this particular class that this particular variable which we are initializing belongs to the class CNN. So I'm creating convolution one variable. Exactly, kernel means filter. So number of kernels means number of filters. You can reuse kernel in place of filters, filters in place of kernels. So I'm defining first convolution layer. So in neural network, that is NN, we have con 2D available. We will be using it. You can see it needs input channel. What is the input channel of your data? I'll answer the queries there in the chat box. First of all, let me know what is the input channel of your data. It's 3. So input channel is 3 because the image size is 32 cross 32 cross 3. So that's why we have to write 3 here. Now what is the output size you need? Output channel will be is the number of kernels. So that's why 32 will be here. So there is a query in the chat box that why is the third dimension is 32 instead of 3. Earlier we had 32 cross 32 cross 3. Now we are getting 32 cross 32 cross 32. Why? You are getting the output size as 32 cross 32 for one kernel or one filter. There are total such 32 kernels available. So that's why the output size of the first convolution layer will be 32 cross 32 cross 32. So whatever will be the size of, whatever will be the count of number of kernels or filters, that will be the channel of your output. So suppose in place of 32, we had 16 kernel. So in place of 32 here, you can write 16. So this is done, input channel is done, output channel is done. Similarly, you have to define the kernel size. Kernel size or filter size. So we have defined it as 3 and padding we have to define as 1. Stride also you can define as 1, but by default the value of stride is 1. So that's why we are not writing. If you make it as 2, then definitely you have to write. Similarly, if you want to make padding as 0, no need to write because we are making padding as 1. So that's why I'm writing padding is equal to 1. Is it clear to you all? The first convolution layer is clear. Can we go ahead? After this layer, your input size and output size is same. The only difference is number of channels. There is a query why we are not defining this the stride value. Stride value definitely you can define. Stride value is by default 1. So no need to define. If you want to write, you can like write here strides is equal to 1. Similarly, if I will not write padding is equal to 1, that means it will count it as padding as 0. So in this case, your output will be in place of 32, it will be around, I think, 30 cross 30. So that's why stride is not necessary if you are not changing the stride value from 1 to any other value. Similarly, padding is not necessary if you are changing the padding value from 0 to anything else. So input size and output size after first convolution layer is same. Now next step is you can even apply another convolution layer, and number of convolution layer you can apply, you can see. But it's a quite small size data set, small size in terms of pixel, 32 cross 32 cross 3. So no need to use multiple layers. So instead of that, I'm using pooling layer here. So that is also available in NN dot max pool 2D Here you have to tell the pooling size you want. So I'm pooling it to 2 cross 2. Can anyone tell what will be the size after pooling this particular 32 cross 32? If we will be pool, then output size will be, just tell me in terms of normal RGB, like channel last scenario. What will be the output size if you will apply pooling 2 cross 2? No, 8 cross 8 will not be the answer. Why everyone is saying 8 cross 8? It will be 16 cross 16. I'm talking about normal channel last scenario. I'll write here because the input I have taken is channel last. If you will replace channel last to channel first, that is here, then every last channel will be swapped. So 16 cross 16 cross 32 will be the output size. After pooling layer, you will be getting the size as 16 cross 32. Is it okay? Next is again we will be creating another convolution layer. Self.con2 I'm going to create, and this time you have to tell me the output size. So I'm using con2d. First of all, what will be the input channel? So that formula, there is a query for formula for pooling. We are using pool size 2 cross 2. That means you are just dividing the previous size by 2. So previously we had 32 as size divided by 2. So we are getting 16. 2 cross 2 is height and width. Both you are pooling with 2 cross 2 filter. In theory, you must have studied max pooling, min pooling like that. So 2 cross 2 is you are max pooling kernel of size 2 cross 2 and getting the maximum value of 2 cross 2 kernel. So if 2 cross 2 is replaced by one value, so your entire image is reduced to 16 cross 16. Stride is not there. When you talk about pooling, let me explain you with some picture. In pooling, you don't have any kernel in same as convolution. When you talk about 2 cross 2, that means this initial 0, 1, 0, 1, 0, 1. So two values are there, two in width, two in height. So max pool in 2 cross 2 max pool. That means you will get maximum value of these 2 cross 2 pixel. So maximum is 20, you will be getting 20. Now the stride value will be 2 here, not 1. Whatever will be your pooling size, your stride will be shifted to 2 times. Like if your max is 3 cross 3, it will be shifted 3 times. So next is this second value. So 30, 0, 2, 0. So the maximum value is 30. That's why 30 is in the output layer. Similarly, you will be passing to the, like when you talk about height, again the stride will be 2. You will be skipping the previous 2 rows. So here 112 will be the output. Similarly, for the last 2 cross 2, the output will be 37. That is maximum. Is it clear about max pool? So stride is dependent on the whatever will be the size of your pool. Can anyone tell what will be the input for the first parameter of con2d? Okay, because the number of channels in the output layer is 32, so that's why 32 will be the input channel. Next is about the output channel. Output channel is hyperparameter. You can even make it 32, you can make it 64, you can make it 124. So I'm setting it as 64. The kernel size is 3 we are going to use. And padding, I'm not reducing the size from here, so that's why padding 1. Now tell me the output size of this particular convolution layer through the previous formula. There is a query why it is 64. So this is a hyperparameter. You can even make it 16, you can make it 8. Hyperparameter means whosoever is the developer of this particular neural network, he or she can decide what will be the number of filters in a particular convolution layer. So definitely the output of this particular convolution layer will be 16 cross 16 cross 64. 64 because 32 is the input size. Sorry, 32 will not be input size. It will be 16 from here. Sorry, 16 will be here. It will not be 32, it will be 16 because after max pooling, we are getting output as 16 cross 16 cross 32. So the input will be 16 here and output we are going to use 64. So that's why here you will be having 16 cross 16 cross 64. Next is input channel is okay. Sorry. I'm little confused. So the 32 will be from here. I'm confused a little bit. So this is from here. That 32 will be from here, and this is 64. The output we will be getting is 16 cross 16 cross 64 from here. So this is about your convolution layer, pooling layer, and con2 layer. Other than that, we will be applying pooling again. Instead of defining this pool again, I will be reusing this pool layer. So I'm just commenting in the forward pass, pool 2 will be used using pool layer. So what will be the output size when you apply pooling again? This is about initializing, so that's why defining pool 2 is not that much necessary. What will be the pooling size of same 2 cross 2? It will be 8 cross 8 cross 64 after second pooling layer. Now, the output we have 8 cross 8 cross 64. You can even create more convolution layer and pooling layer, or you can just finish it here and then convert your output into one-dimensional array so that it can be compatible with the dense layer or linear layer of PyTorch. So we call it as fully connected layer or multi-layer perceptron, whatever is okay with you. So I'm creating one fully connected layer. Here, the input channel will be 8 cross 8 cross 64, or you can write 64 cross 64 8 because it's about channel first. So this is your input. Non-linearity layer we will be adding Second pooling layer is not missing. When we will be writing the forward pass, we will be appending everything. Whatever is you can see is not available here, that will be there in the forward pass. This is just initialization. So the input will be 64 cross 64, 64 cross 8 cross 8 of input, and then the output will be again hyperparameter. Similar to 64, you can make it as 64, 128, 256. Suppose I'm making it as 128. Similarly, I will be creating another layer, self.fc2. Just a minute, nn.linear I have not written, sorry. nn.linear, that is the dense layer of pi dot. So nn.linear, the input here will be the output of previous layer. So that is 128. And then the final output will be the number of classes we have in the output label. So we have 10 classes, so I'm using 10 here. So this is defining the important parameters or variables of your neural network. Now, next is about second pooling layer is missing, non-linearity layer. Ma'am, the output layer of fully connected layer will be the equal number of labels in the classes. Definitely, we have done that, but it is in the second fully connected layer we have done, because here directly if you will be converting 64 cross 8 cross 8 to 10, then some information may be missing. So that's why I'm creating another layer. Let's go ahead with the forward pass. So whatever is missing there, now we will be connecting one to, you can see every component is currently not connected. In the forward pass, you have to connect your component. Your input, that is X, first of all pass to convolution 1. Then whatever will be the output of your convolution 1, that will be passed to pooling layer. From pooling layer, output will be passed to con 2. From con 2, again pooling 2. From pooling 2, it will be passed to fully connected 1. And from fully connected 1 to fully connected 2. Like that, it will be following the interconnection of or the steps or sequential occurrence of your neural network. So let's go ahead with that. First of all, your data will be passed to con 1. Con 1, so that you have to define like self.con1, pass your data. Now, whatever of the input of your this particular self.con, that will be passed to the non-linearity function that we can use. Suppose we are using ReLU here. So torch dot ReLU, all the activation functions are there in the torch. So you can use torch dot ReLU to add add non-linearity to your output. It will be again passed to the pooling layer. So cell.pool, and this is again I'm storing in variable X. So first of all, X is passed to con 1. From con 1, it will be passed to ReLU. The output of ReLU is then subjected to pooling layer. This is first step, and again stored into X. In the next step, self.con2 will be having input X, that is the output of pooling layer, that is again subjected to value activation function, and then again the pooling layer. I'm using same pooling layer because there is no first of all filter involved in the pooling layer, and similarly there is no change in pooling function. So I'm using the same variable here as well. And again, I will be storing it in X. Now, you can see after second pooling layer, our input is 8 cross 8 cross 64. That is multi-dimensional or three-dimensional, we can say height, width, and channel. So we have to convert that into one dimensional. One dimension you have to convert. So for that, reshape is there in Keras or NumPy. Here we have the function view available. So that we will be using x dot view. We are using, first of all, -1. -1 is the last channel that will be converted as 64 cross 8 cross 8. So it will be flattened. Now you will be having output as batch, comma, multiplication of 8 cross 8 cross 64. Last channel. -1 is when you access any list like this, -1 tells you that you have to read it from the last. So we are replacing the last value, reshaping it as 64 cross 8 cross 8. Now we will be calling FC1. So self.fc1 will be having x, so I have to store the value of reshape in x, and then again dot value. Again, we have FC2. So it is not subjected to any type of non-linearity because we will be using the loss function, cross entropy loss. That is, first of all, apply a log of softmax. If you will use softmax 2 times, then there are chances you will encounter any type of error. So that's why directly x, and then returning the value x. So this is your neural network model. Any doubt in this, please let me know. I'm copying the code in the chat box. So there is a query after FC2 will not do softmax node here. In PyTorch, you need to use softmax layer at the end. You'll find out that some are using, but when you see the PyTorch documentation, when you use loss function as cross entropy loss, it includes log of softmax along with it the cross entropy loss. So if you use 2 times softmax, then your result will be hampered. So that's why we are not using softmax. Just read the documentation of PyTorch. You can see it is giving you log of softmax first of all. And then it will be giving you the output. So that's why we are not using the softmax function. But if you need the probability, then you have to use softmax during the testing, not training. Now the queries are what does nn.linear do here? Linear is about dense layer. You must have studied artificial neural network where you have input layer, hidden layers, which are densely connected with that is replaced in PyTorch using linear function. Next is where we have used cross entropy loss. Here we will be using cross entropy loss after some time. So just wait for a while. Next is please resend the content. Definitely the complete notebook I will be sending it to you. Let's go ahead with the next part. That is passing your neural network that you have created to GPU memory. That is explicitly you have to write in PyTorch. So first of all, let's initialize the device. So the torch dot device is CUDA. CUDA is about GPU. If torch dot CUDA is available, if it is not available, then the device value will be CPU. So this is the way we will be defining the device. Next is passing your model, that is CNN, to device. Model is equal to CNN, and then we will be passing it to device. It is saying that torch.nn has no attribute. A C I have to write in capital letters. Now our model is passed to the GPU memory. Now you have to define two things. One is the loss function that just now I talked about, categorical cross entropy loss. And the second is about optimizer. So optimizer is helpful for weight update process. There are multiple types of loss functions available as well as optimizers available that you may have gone through during your theory session. So SGD, RMS drop, ADAM, ADA delta, ADA grade, multiple optimizers are there. Similarly, in the loss function, you have sigmoid. You can use cross entropy loss. You can use RMSE, root mean squared error, MSE loss, focal loss. Multiple type of loss functions are there. Based on your objective, you can use any type of loss function and optimizer. So first of all, we will be defining the loss function that is named as criterion in a local variable. So in the neural network, we have cross entropy loss. Similarly, you have to define optimizer. So in torch dot optim, you have item optimizer available. So it takes two parameters. First of all, the parameters of model. So parameters of model is about weights and biases. And the second is the learning rate. So let's make it as 0.001. So generally the optimizer we can use SJD, RMS, from ADAM, ADA grade, ADA delta. You can try with different combinations. You can read the documentation and try it to check which one is performing best with your data. Next is about learning rate. That is again hyperparameter that you have to decide. But when you read the research paper, you will find out most of the time the value of learning rate is generally 0.001 or 0.0001, 0.005, 0.0005, like that. It should not be too small or too large. The queries, I'll resolve the queries after some time. Just give me a moment. When the training process will be under process, at that time I'll explain the queries. Is it okay? Or just let me read what are the things. This is done, cross entropy loss. Yeah, madam, please send the content. I'll send the complete notebook at the end. We are calculating. So, Mr. Javed Hossain, what we are calculating manually? Manually, we are calculating the input of linear layer. We are saying about this. There is no automatic way. You have to check whatever is the output size of your last layer, that you have to write here. criterion and optimizer. No need to define criterion and optimizer in the class. You have to define it outside the class because you have to pass. When you define it inside the class, you cannot use it outside the class. So define it outside the class. In the training process, you will need criterion and optimizer. Then the query is what happen if LR is too large. So if possible, if I have that particular, I can find it out. That animation I can show you. If the learning rate is very small, then there are chances that you will encounter two local minima. If learning rate is too large, then the fluctuation in your learning graph will be too much and it will be just shuffling here and there and going from one place to other place. It will not encounter any type of local minima at that time. I will have that particular animation. I can find out from somewhere. I'll show you. So you can see this is the very first image I'll explain you. If your learning rate is too low, then it will not reach the smaller learning rate is reaching the minimum point will be quite difficult. You will, because your graph will not like this. It will be like there will be too many slope and then like this you can see 3D way. You can see there will be too many places where you can find the minima. If it is too large, then the behavior will be like this. It will be going from here to there, here and there like that. It will be just moving from one place to other place. So that's why it should be not too large or not too small. Other thing, let me read other queries and then we'll go ahead. The queries, so ma'am, only init and forward pass only we need to define inside the class. Yes, you have to define only two functions. Currently, the basic neural network, because this is a basic one, so init and forward. If you have a large neural network, you can divide your forward pass into small sub modules. Individual module will be dedicated for different processing. But currently it's a very simple two-layer model, two convolution layers are there. So that's why we don't need more functions here in the CNN class. How to decide the learning rate? There all the hyperparameters are, you cannot decide. There are two ways. One is either try with multiple things, multiple combination of hyperparameters, or you can use various game theory based approaches, optimization based approaches to select the best learning rate for your data. Generally, if you don't want the optimization or game theory based algorithm, we set it as 0.001 or 0.0001. So let's write the training function and then we'll go ahead. So I'm using the progress bar using TUGDM. So I'm using, first of all, importing TUGDM or TQDM. Then I'm defining the training function. In the training function, first of all, you have to pass your model. You have to pass your training data because this is about training. Then you have to pass your optimizer and then criterion, that is your loss function. Before starting the training, TUGDM is a library used for showing the progress of visualization tasks. So I'm using that particular library here. Next is about training your model, defining that. So first of all, you have to set your model as train. So name of the model is model.train I am setting so that it will be training mode. The training mode tells that your model will be in weight update process. All the weights and biases will be updated after each batch of the data. I'm using few variable, initializing few variable. Loss will be in float, so I'm using it as 0.0. Then we will be using, for accuracy, I'm using variable correct, so it is 0, 1 like that. So defining it as integer, that is 1. Then I'm using counter to count the samples, so that is 0. Now we have the data in train loader and test loader. For I comma data in TQDM, this is about showing the progress, so that's why. First of all, we have to enumerate over the train loader and it requires the total length. So that will be length of your train loader. And then the counter will be increased. Next is you have the data in this particular data variable, which contains both images as well as labels. So one batch is accessed from the data. In one batch of training sample, you will be having some, I think 32 images. 32 images will be there. Next is similar to passing the model to GPU memory. You have to pass the data as well to GPU memory. So let's do that. Similarly, you have to pass labels to GPU memory. Now, you have to make your optimizer as 0 gradient. Set all the gradient as 0. Optimizer dot 0 underscore grid. After setting the 0 grade all the optimizer, you have to perform the forward pass. Forward pass means you are passing the data to the model. We have the model here in this particular variable. Next is passing the data. Data means you have to pass images here in the model, and whatever output you are getting, that you have to store in a local variable. So this is your forward pass. This is your forward pass of your function. This particular forward pass is called using this particular function. After that, we have to calculate the loss. So the loss calculation is done with the help of criterion. In criterion, you have to pass the actual label as well as the predicted one. So these are the predicted labels. These are the actual label. It will be calculating the difference between the actual label and predicted label. And loss function is loss value is calculated. Now we have train running loss variable with us. That is stored as that's equal to loss dot item. So forward pass is there, loss calculation is there, and next is about back propagation. Loss calculated. Now you have to back propagate the. Just two more things. Now let's calculate the accuracy as well. We have here the output. We have to calculate the maximum value of this output. So torch dot max outputs dot data, comma 1. It will give you two things, but we only need the prediction of, not probability. Now we have defined the train running correct. If the values are same, then the counter will be increased for running correct. Otherwise, it will not be. If the value of predictions is equal to labels sum, because there are multiple images in a batch, so that by sum, then the value of training run correct will be increased. So this is about calculate. Let me just complete the things and then I will be answering the queries. Calculate the accuracy. Next is back propagating the loss. So that we can do using loss dot backward function. Next is about optimizing the weights. So that you can do with the help of optimizer you have defined. So optimizer dot step, and through which the weight update process is performed. So this is backward propagation. Backward propagation you may have studied in the theory class as well. And this is about weight update process. So this is all about a single batch functionality, and through for loop all the batches will be passed through the entire process. Now after all the batches you need to calculate the epoch loss and epoch accuracy that we will be doing now. We have train running loss. That will be divided by the counter. Similarly, epoch accuracy, that is 100 multiplied by, we have train running correct, divided by length of the train total dot data set. And now we will be returning the epoch loss and epoch accuracy. Next is about training. Once the training will be started, I will be resolving all the queries you have. So on board time, epoch, I'm setting it as 10. Then I'm creating two lists to have the loss and accuracy detail with me. And now we will be running the loop for epoch. So for epoch in range, epoch, so it will be starting from 0 till 9. What we have to do, we have to call the train function, which will be having four parameters: model, train loader, optimizer, and criterion. So model, train loader, optimizer, and criterion, and it will be returning you loss and accuracy that we have to append in train loss and train accuracy variable. Now next is printing the data. No voice because I am not saying anything. I was just writing the code. I just want to finish this particular code and then I can answer the query. Anything else? So Tugdom is helping me to create this type of progress bar. And this is about training. I'm just copy pasting the code in the chat box so that you can also run in your notebook. And if you encounter any type of error, if there is any query, let me know. Definitely writing the code in PyTorch is little time consuming and like tedious, but once you are familiar with PyTorch, you'll definitely love it to work with PyTorch for your problems. There is a theory why we are defining train planning loss with counter because we need it. Counter will tell you the batch, particular batch, one batch, two batch, like that. So total batches, dividing it by total batches necessary to have the particular epoch loss. Similarly, we are doing it with the accuracy as well. There is a query, can you just reframe it? In the morning session, we have learned there is a channel to create convolution neural network where we are implementing it. And this is here. Channel is this. In 32 cross 32 cross 3, 3 is the channel. Similarly, 16 cross 16, the channel is 32. If you're talking about kernel, so kernel is different thing and channel is different thing. Can you just rephrase if I'm not wrong? Are you talking about kernel and filter or channel? Again, the next query is this model image. This is nothing. You are calling your model, this particular model. In the model, whatever is the forward pass, that will be executed. When you call model, pass the image. This image is treated as X, and these steps are executed. The output is returned back and stored in this outputs. There is another query, how we know that torch.max gives two outputs. So this is predefined function. So that's why we know that it will give you two outputs. You can see it's giving you, let me take not this one. Here we are using one-dimensional array. So we want to use two-dimensional. This is different. This is about x's. So that's why we need only one value. That is the prediction of highest value label. Yes, in CNN, you have to define only the model structure. The training function will be outside defined. Similarly, we will be defining the test function. Once the training, now you can see the training is finished, the training loss is 0.191. Now we have to run it for test data. So I'm defining test function. This time I'll not use structure test. Here optimizer is not needed because we are not doing weight update process. Next is about, instead of model train you have to use model.eval. And here also one more line you have to append, that is with torch dot no grad. That means you are not using any type of gradient. Now, instead of train loader, we will be using test loader. Counter we will be using. Images and labels will be same, but this time it will be accessed from test loader. Zero grade is not necessary, but this one is necessary. Instead of train running loss, this time we need test running loss. Similarly, test running accuracy. Loss backpropagate optimizer steps are not required. And when you execute this particular, just make it as test loss and test accuracy. Test loss, just print it. The loss value, it will be nearby 0.19, something greater than that. 0.0025 for this, and then for accuracy, training, ACC. There is something missing. Let me just check it once. This it will be test loader in place of train loader. Again, few more steps I have to check. Test running loss, data, images, criteria, test running loss. Because it will be not like this. Let me just recheck the test function. In some paper, the training accuracy is 99%. Yes, it is correct. You will get the accuracy 99 even. I'll use the simple text loader. I will show you how results are affected. First of all, model evaluate. We are testing. Test running lost. Counter we will be using low grade. And test loader we will be reading. Okay. This will be inside the loop. This is the thing which was causing the issue. So the accuracy we are getting is 70.73. You can see again I'm getting 70.73. How many times you run, you will get the same result. But if I will say shuffle is true, the performance will be changing for test loader. Is switched by slow. Means some test function is there. Okay, it is defined initially, so that's why it is accessing the data from there. So, or maybe they have changed. Otherwise, in Caret as well, if you will change the batch size, like this test law, this shuffle from true false to true, your performance will change. Now it is not changing. That's good thing. And any other query, if you have, definitely you will get accuracy 99%. If you use any pre-trained model or if the model is properly trained, sometimes it is about overfitting as well. How to go about learning the coding tactics with since you know the structure. This is your overall structure of a convolution neural network in uh, what we can say in PyTorch environment. Now, if your data changes, you have to just change the convolution neural network parts. Training will be similar, testing will be similar. No need to touch these parts. Just change the structure of your model and you are good to go. Any other query participants? Okay, let me show you. It's what it is. when you run this plot.max, you will be encountering two things. One will be the values, and then the second one will be indices. We only check the indices, we don't need the values or the probability it is calculating. We only think about the indices or the label so that we can match it with the label. That's why we are ignoring the first part, only using the predictions. Because in output dot data, we print that as well. We'll see this type of data you will be having in your output, that are the probability of each object for a particular class. What is another thing? One more brief review of code from training to testing, ma'am. Okay, I'll revise it. Can we pass an image and check its performance? Definitely, we can do that as well. Ma'am, you didn't run the test loader again after making changes. That's why it is. No, I'm running that. I'm loading the test loader, test function, rerunning. It is not changing. The accuracy is not, it is fixed. It is fixed. It is not affecting the performance. Next is we want to show the prediction on some new data. So that also I'll explain. We have images, suppose in this test loader. And let's okay, from test loader we have already like visualized the images. Just let us take the images which we have shown here. Similar code, this code we will be using, and then changing few things, few lines, so that it will be completed within 2-4 minutes, because now we left with only 2 more minutes. If not basically. First of all, we have to unnormalize our what we can say, unnormalize our images. That is again like not necessarily that much. We have the data in some iterator we have created. So we can access the data from there. I don't know. Okay, this is the images and labels we have. We'll use the same images and labels for prediction. Let's check the images dot shape. There are 8 images and labels are 3880661. Just pass. Look, I'm storing the outputs and passing the data to model. Data is there in the images, but our data is not in the GPU memory. So when you run, it will encounter error that data is not CUDA. So images dot to device you have to run. Now you have outputs. When you check it, it is in the form of probability. So what you have to do, you have to just use this take the predictions, and then this is your predicted labels and this is your actual labels. So you can see 3 is okay, 8 is okay, this is mismatched. The index number 2, 0, 1, 2. Index 2 is incorrect, 3 is correct, 4, 5, 6, all other are correct. Only one index, that is index number 2 is incorrect. This is the way you can use your model for new image prediction. I'm just re-explaining the complete code in a minute. First of all, we have created the transform that is for pre-processing, convert the data to tensor and normalize the image. Then we have read the data from the Torch Vision dataset package. The CIFAR-10 dataset is there, storing it to sample data, and then train to and just to download the train data and false to download the test data. And this is about transform or pre-processing step. Then loading the data in the form of batches. These are the classes we have. Then iterating over the data to access the image and labels and print the data. Then a convolution neural network we have developed. In the class, there are two functions. One is init and one is forward path. In init path, you define the variables. In forward function, you provide the forward path. You connect the dots between these init variables. Then we are passing the model to the GPU memory, creating the loss function and optimizer. And this is your training part. In your training part, the steps, these are unnecessary, like this TechDem and running loss. These are not necessary steps. The necessary step is accessing the data, passing the data to device, making the optimizer as zero grade, performing the forward pass, calculating the loss, and then back propagating the loss, and then update the weights. These are the necessary parts which I have commented. It just accept accuracy. So let me just download this particular notebook and I'll write it, copy it in the chat box for your help. If there is no other query, can we conclude the session? Participants, if there is no other query, can we conclude the session? I have uploaded this particular notebook in the chat box. Just run it in your system. I just stopped in between, so that's why this particular line is there. So thank you very much, participants. If there is any other query, you can write in the chat box. If not, thank you all. For splitting the data, like training and testing is already there, you can split the train data as well. Thank you all.
Thank you so much, ma'am.